in ray optics, so some informations, okay, what we have assumed about that light is listed here. Let's go through them. Human eye can see or it is sensitive to a small part of electromagnetic radiation. This part of the electromagnetic radiation is called as the visible light. You might have already come across the different parts of electromagnetic radiations like gamma rays, X-rays, ultraviolet light, visible light, infrared radiations, microwaves, radio waves, etc. But all these radiations we can't see. Our eyes cannot see. Okay, only a small part of the electromagnetic radiations can be seen by human eye. So this part is called as visible light. This part is called as visible light. What is the range of the wavelengths of the visible light? Our eye can see the light from 400 nanometers to 750 nanometers. And when this wavelength changes, our eyes perceive it as a different colors. So from violet to red color, Vibgyar, violet, indigo, blue, green, yellow, orange, and red. These are the visible light with different wavelengths. When the wavelength changes, we see them as a different colors. And it is found that light travels in a straight line. And it travels with a very high velocity. What is the velocity of light? It travels 3 into 10 to the power of 8 meter per second. Remember that it is not minus 8. It is a very high velocity. It is plus 8 meter per second. 3 lakh kilometers per second. Extremely fast. The fastest, thing which we come across in physics. Yes. The path of light, here we consider that as a ray of light. The path of the light is considered a ray of light. Many rays of light moving in the same direction makes a beam of light. The bundle of the rays makes a beam of light. Sometimes we take a beam of light coming from a source of light that contains many rays traveling in the same direction. Yes, by using the ray nature of light, we may explain some phenomena of light like reflection, refraction, and dispersion of light in this lesson. What do you mean by a reflection of light? What do you mean by reflection of light? Actually, we are supposed to learn the reflection of light by spherical mirrors, but already in your lower classes you might have learned about reflection of light by plane surfaces. And there you might have studied few laws also regarding the reflection. What are the laws of reflection? There are 2 laws of reflection. The first one states that the incident ray and the reflected ray and the perpendicular drawn to the surface at the point of incidence, all these 3 rays are confined to a same plane. They all lie along the same plane. The incident ray, the reflected ray, and the normal lie in the same plane. That means the incident ray and normal in one plane and reflected ray in another plane is ruled out. Suppose if the incident ray and normal are on the plane of the screen, you can't expect the reflected ray to come out of the screen. All these 3 rays must be on the screen. Angle of incidence, I. What is the angle of incidence? It is angle made by the incident ray with the normal drawn to the surface. From this side you have to measure. Normal is the reference line. The incident ray is the angle made by the incident ray with the normal is equal to the angle made by the reflected ray with the normal. If the angle of incidence is I, angle of reflection is R, then it is found that angle I is equal to angle R. The angle of incidence is equal to the angle of reflection. Okay. You know about this information. But they say that the laws of reflection, the same laws of reflection, is applicable to the reflection of light by spherical mirrors. Spherical mirrors or spherical surfaces also. The above laws are true for reflection at a point on a curved spherical surfaces also. Let's take a curved surface. This surface is curved in and it is called as, this surface is called as concave mirror. It is a concave mirror. Concave mirror. Concave mirror. Okay. Yes. Concave mirror. And this point is called as the center of curvature of the mirror. If you take the closed part of the spherical surface as the C acts as the center of the sphere. Okay, because we consider mirror as a part of a spherical reflecting sphere. So the center of the sphere, the C is called as the center of the sphere. Okay. And the point, the middle point of the mirrors are called as pole of the mirror, and it is represented by the letter P. The line joining the center of curvature of the mirror and the pole is called as the principal axis. We are going to learn all of them. Okay, principal axis. Okay, here. So, this is the incident ray. Incident ray. Incident ray, okay. And this principal axis. It is found that principal axis makes a 90 degree. It's considered as a normal with the spherical surface. The radius always makes a perpendicular at any points on the circle or on the sphere. Hence the principal axis makes a 90 degree. Hence you can consider this as a normal or a perpendicular. You can consider this as a normal or a perpendicular. Yes. What is the angle of incident? The angle of incidence is the angle made by the incident ray with the principal axis or the normal drawn to the surface at the point of at the point of incidence. And what is the angle of reflection? It is written as R, the angle made by the reflected ray with the principal axis. And it is found that the angle of incidence is equal to the angle of reflection. It is true even for curved surfaces. Plus, if you take one plane and the plane contains incident ray, reflected ray and the normal, drawn to the points. All of them, incident ray and normal and reflected ray, they lie on the same plane. Next, let's learn what's meant by the focal length of the spherical mirrors. There are two types of the spherical mirror. One is called as the concave mirror, the another one is called as convex mirror. So these two together are called as the curved mirrors. Curved mirrors. Okay. Yes. What is a concave mirror? This concave mirror is a curved in mirror. Curved in mirror. How to write the concave mirror? How to write the concave mirror? You should write a one. So curve, and then you should so just mark the slant lines to show the silver. It is silvered outside. Reflecting surface is inside. The reflecting surface is inside. That's how to write the concave mirror. So concave mirror. That's how to write the concave mirror. Yes. So take a concave mirror. if a light from a distant source which is traveling parallel to the principal axis, incident on the reflecting surface, it is found that after reflection it passed through some fixed point on the principal axis. That fixed point is called as focus. Focus. All the lines, all the rays of light, when they travel parallel to the principal axis, and after reflection it is found to pass through a fixed point on the principal axis, it is called as the focus. Focus. The focus is towards the left side, or we can say it is the same side of the concave mirror. Concave mirror is also called as converging mirror because a beam of light traveling parallel to principal axis converges to a one point called as the principal focus. Okay, yes. Next, so yes, this type of bulged out or curved out mirror is called as the convex mirror. How to draw the convex mirror? Again, as usual, you should draw a one curve and then you have to silver inside. So you should silver inside. Okay, the reflecting surface is outside. Okay, generally this is how it is represented. So at the center point of this can be considered the pole. Any ray of light, any ray of light. So any ray of light when moves parallel to the principal axis, it is found that after reflection it comes out from a point on the principal axis. It comes out from the point on a principal axis. This point is called as the principal focus. It's called as focus. Okay, so the rays of light, when they move parallel to the principal axis, they get diverged. That's why this is called as a diverging mirror. But it is found that they diverge from a one fixed point on the principal axis. It is called as the focus. So these are the two curved surfaces. One is called as the concave mirror. Another one is called as the convex mirror. Yeah. Sometimes what happens? Sometimes the incident ray from a distant objects may incidence at an angle on the spherical mirror. At an angle on the spherical mirror. At that time it is found that all these rays are focused, or all these rays are focused on a plane. So the rays do not focus, the rays do not meet at the focus. But the rays meet on a plane. The plane passing through the focus. This plane is called as focal plane. So that plane is called as the focal plane. Yes. When the rays of light from a distant objects which is coming parallel, means all the rays of light traveling parallel, but not along the principal axis, but makes some angle with the principal axis. Then after reflection they meet on a point. On a plane called as a focal plane. Okay. Yes. Now let's take any reflecting surface. The reflecting surface is represented by say Mn. You can just take it as a M and N. So Mn. So this M and N is the reflecting surface. And P is called as the geometric center of the mirror. Mirror is three-dimensional. It's a flat, means it is a flat surface, but it is curved in. The exact geometric center is called as the pole. So this is called as the pole. So pole of the mirror. And if you, yes, pole of the mirror. And if you take the whole sphere, okay, where the mirror is a part. So take a whole sphere where the mirror is a part. So there is a one, okay, the center of this sphere, that center of the sphere is called as center of curvature of the mirror. Center of curvature of the mirror. Yes. Okay. Yes, they'll take the distance from the center of curvature to the pole. Always the distances are measured from the pole. Okay, in sign conventions, later you are going to learn that all the distances must be measured from the pole. The distance of the center of curvature from the pole is called as radius of curvature. Radius of curvature. And we also studied that any ray passing parallel to the principal axis after reflection pass through the focus. Pass through the focus. Yes, pass through the focus. The focus is at a some distance in front of this concave mirror, and this distance from the pole is called as focal length. So focal length. F is the focal length. F is the focal length. F is the focal length. R is the radius of curvature. And the line joining the center of curvature and the pole is called as the principal axis. The line joining the center of curvature and the pole is called as the principal axis. Okay, right. Now we have to, okay, so we have to learn the derivation of radius of curvature R and focal length F. How are these two physical quantities are related? Okay, yes. Right. So for that you have to write this ray diagram as shown here. Consider an incident ray AM passing parallel to the principal axis. After reflection, it passes through the principal focus F. Here C is considered as the center of curvature and F is the principal focus, and PF is called as the focal length, and PC is called as the radius of curvature. Yes. M. What is M here? Point of incidence. Drop a perpendicular from M to the principal axis. It is found that this P and D are very close. So even though MP is a curve, but for all practical purpose, we can take that D and P are same. For thin lenses, the D is very close to P. Hence the line MP and MD is assumed to be a perpendicular. So you can assume that this line, okay, MD is a perpendicular drawn to the CP. Okay, right. What is the angle of incidence? Here theta is the angle of incidence. What is the angle of reflection? Again theta is the angle of reflection. So angle of incidence and angle of reflection. What is the normal? As usual, any line pass written, okay, through the center of the surface is considered as the normal. Okay, can consider as a normal. That's the normal. So this line is normal. And already we have learned that angle of incidence, if that is theta, this is also theta. Okay, yes. Now, okay, so a little bit of geometry have to apply. Okay, yes. Take this triangle. For this triangle, you can say that if this is angle theta, this is also angle theta, because these two lines are parallel line. As these two lines are parallel line, these two angles are equal. If that is theta, this is also theta. Okay. right? And similarly, so as these two lines are parallel, and when this angle, if it is 2 theta, it is found that even this angle is also 2 theta. So therefore this angle MFD is 2 theta. This is 2 theta. Yes. So this is the extra information that you are supposed to write. So AM is moving parallel to the CP, and if this angle is theta, this is also theta, alternate angles. And again, so because these two lines are parallel, if this angle is 2 theta, this is also 2 theta. So that you should remember. And then so you should so yes, for thin lenses, D is assumed to be very close to P. In the triangle MDC, so by using the diagram, you can just write DC. In the triangle MDC, tan theta is equal to, what is tan theta is equal to? So tan theta is equal to opposite side by adjacent side, MD by CD. It is found that for small angles in trigonometry, tan theta can be considered as theta only, the angle only, but the angle must be in radians. Tan theta is theta. So hence you can put tan theta as a theta. So therefore the theta is equal to MD by CD. Theta is equal to MD by CD. Similarly, in this triangle, MDF. So tan 2 theta. So you can just write as tan 2 theta can be written as opposite side MD. MD divided by a FD. MD divided by FD. Again for here, for small angles, so tan 2 theta can be written as 2 theta. So 2 theta is equal to MD by a FD. MD by FD, opposite side by a adjacent side. So here for small angles, theta is equal to MD by a CD. Tan 2 theta is equal to tan 2 theta is equal to MD by FD. Now you can divide these two equations. Equation 2 by equation 1. 2 theta by a theta. Theta get cancels. You will get just only 2. Here MD by FD divided by MD by a CD. And just take the reciprocal of it and divided by is converted into a multiplication mark. MD get cancels, and you will get CD by a MD. CD by MD. Yes. Now again let me bring back the image to this screen. Prove that so 2 is equal to CD by MD. What is a CD? So here the CD is approximately can be taken as the radius of curvature. And what is FD? FD is nothing but the focal length. So FD is approximately taken as the F. So hence, so CD by MD is equal to radius of curvature by focal length. If you cross multiply, you will get focal length is equal to half of the radius of curvature. Or radius of curvature is equal to 2 times the focal length. Yes, this is the simple derivation. Already in board exam in NCERT 12th. So board exams, CBSE 12th board exam, already they've asked these questions. So you can just practice deriving the relation between the radius of curvature and the focal length. So by using this information. That's all students for this video. Thank you very much for watching. So please don't forget to subscribe and like this video and comment. Please comment which concepts you need immediately. In the comment session, if you mention, I'll try to bring over those videos to you. And also please help me by sharing this video, and you can keep watching as many times as possible, so that saves you a lot of time by preparing yourself from the books. Okay, yes, and this information can also be uh, taken as the notes. You can just watch it and write it again, and that forms an excellent notes for you. Okay. Thank you very much, students, and yes, keep waiting for my the new videos, okay, containing the very big okay derivations of the ray optics explained in the simplest manner. Thank you very much.